This is your second review sheet, multiple choice. Figure out. Okay, here we go. All right, so you got more questions. Let's see how you do them. So here we go. So this is an order of operations question. And we're going to do parentheses. Not parentheses, right? Grouping, sorry. Exponents, multiplication or division coming from left to right, and addition or subtraction coming from left to right. So here we have two parentheses. Let's take care of each one inside. So 8 minus 3 is 5. I'll leave it in parentheses, the second power, minus 5 minus 2 is 3, and again to the second power. Now we can take care of the exponents. 5 to the second power is 5 times 5, which is 25. 3 to the second power is 3 times 3, which is 9. And we have a final answer of 16. And this one looks the same. So actually don't read the whole question, which is what I didn't do. Okay, because there was no, well, I did everything, but I ignored, I should say, the multiple choice here. So look at your multiple choice, read the whole question, look at the multiple choice, and that multiple choice usually gives you a hint of what you should be doing, what kind of answer you should be looking for. Okay, so that one was D. 30. Let's see, a contractor digs a hole for a basement, 40 feet long, 10 feet depth. The width, what is the width of the hole if cubic feet? So this is a volume question, right? And how do I know that? Because it's of this cubic feet. So the answer is, I'm going to write that 6,500 feet cubed. So because it's cubic feet, I know we're talking about volume. So in this, I draw this. What do I know? I know that it's 40 feet long this way, 10.5 deep, up and down. And this line is what I'm missing. So I'm going to put a question mark over here. So we want to know what the width is. So given to us is volume equals, in this case, we want to use length times width times height, because we're given that the volume is 6,510. The length I know. The width I don't know, so I'm going to just leave it as W. And the H I do know, 10.5, which I will change to 10.5. Okay, so this becomes an equation, and what we can do, 6,510. Over here we have 40 times W times 10.5. We can multiply the 40 and 10 times 10.5. That's going to give us 420. So 40 times 10.5 is 420. Our W is still there, right? So I just combine this and this. Now, what can we do? It's a one-step equation. We can divide both sides by 420, divide this by 420, and divide this by 420. So if you have a calculator, I suggest you use it. 6,510 divided by 420. That's going to give us that our width is 15.5. Okay, so looking over here, you had what three numbers multiplied, what length times width times height multiplied would give you 6,510. You were given that the length was 40 and the height was 10.5. So you were missing for this number. And we got an answer 15.5, and we got here. So that's one way of doing it. And again, another way of doing it is if you had this volume equals length times width times height, and you write 6,510. You know that the length is what, 40, sorry. The width, again, is our unknown, and the height is 10.5. So they're giving you these four choices to go for here. You can just substitute. You can go for 40 times 80 times 10.5. See if that works, and gives you 6,510. You can do 40 times 81 and 1/4 times 10.5. 40 times 16 times 10.5, and 40 times 15.5 times 10.5. You could do it that way too. Okay, use multiple choice to your advantage. 31. Only boxes less than 3.5 feet wide will fit through a doorway. What measurements show the width of 3 boxes that will fit through the doorway? Oh, okay. So So there are 3 boxes, right? Each of them have a group of 3 boxes. There's 3 boxes over here, 3 boxes over here. And we want to know which group of boxes, A, B, or C, would fit through the door. So here's a door, and we know that this is 3.5 feet wide from here to here, all the way up here. And we want to put boxes, okay? I'll make these boxes go through that door. Now, this is in feet, this is in inches, so this is definitely a conversion question. So how do you know if 36 inches will fit through 3.5 feet door, or 42 inches, or a 40-inch wide box? How do you know if it's going to fit? Well, let's just change 3.5 to, let's change 3.5. Let's write that as a fraction, as a decimal, 3.5 feet, right? I know that 1 foot is 12 inches. So 3.5 feet, we'll multiply that by 12. That's going to give us 42 inches. So this doorway, another way, this doorway over here, from here side to side, is 42 inches. Okay, it's 42 inches. Let's see, will only box is less than, so it has to be less than 42. Well, this will go through. 42 will not, because it's not less, and this will go through. So A is gone. This one has a 42, no. 43, no. Definitely don't even worry about the other one. 40 inches will go through. 37 will go through. 41 inches will go through. So definitely this way. This one, the 38 will go in. The 40 will go in. The 42 inches will not, because it has to be less than 42. So the only 3 boxes that will go through this doorway is letter C. Particular day, 60% of visitors were students. If 100, 60% of visitors to art museums were students. 144 students visit the museum. How many total visitors did the art museum have that day? Well, percent kind of question, so you can set a percent proportion, 100. You're going to put the percent. Here we're going to go part. We're going to go total over here. So I know that there were 60% of the total population that visited the museum. 60% of them were students. And they're saying that that 60% equals to 144 students. So there were a group of visitors to the museum that day, of which 60%, or in using numbers, 144 were students. So we need to find out how many visitors was that out of. So not only students visited the museum that day, we probably had tourists, adults, and other groups of people visiting the museum. So we got to find this number, right? So 144 students out of 144 out of X amount were students, right? So let's see if we can find a relationship. Is there a relationship side to side? No, but what we can do is we can reduce this, right? 60 over 100, we can change this 6 over 10. We can eliminate 1 0 from each side. So now there is a relationship here, which is times 24. And I'm going to use that same relationship at the bottom, which is times 24. So I get my number as 240. So basically, what this means is that there were 240 visitors to the museum, of which 144 were students, which equaled to 60% of the population visiting the museum that day. Okay. 33. Triangle. What square units of the trapezoid is formed by the 2 triangles? What is the area in square units of the trapezoid ABCD, which is formed by 2 triangles? So let's plot this first. Let me make this a little bigger or smaller. So A is -6 and 7. -6 and negative. I'm gonna make this smaller. I'm gonna make A -6 and -7. -6 and -7, which is about here. B is -6 and -4. -6 and 4, sorry. C is 2 and -7. And D's 8 and 4. 8 and 4. What am I? What is this? Is it a trapezoid? Triangle ABC. Is this a triangle? Yes, it is. Triangle ABC, right? That's a triangle. Let me change colors. And triangle BCD. So, okay, I see. There's two triangles. Right, you can see clearly that there's the blue triangle and the red triangle. And we want to find the area of both two triangles. That's not that bad. So let's try the red triangle. Base times height divided 2. The base is this, from A to C. So this 1, 2, 3, 4, 5, 6, 7, 8 base. My height is from A to B. So it's 7 over here plus 4 over here, so it's 11. Divided by 2, 88. That's going to give us 44 units square. Our blue triangle, the base is here, and let me write D over here. From B to D is our base. So this is 6, and this is 7, so that's our base is 13. Our height is going to be from C. Remember, it's a straight line, so I'm going to draw your height for the blue triangle. This is your height, right? It's going to be 7 over here and 4, so it's 11. I'm going to divide that by 2. And our area for the blue triangle, it's going to be 71.5 units squared. So I believe they want the area, the combined area, so we're going to add 44 plus 71.5. So that'll give us a total of 115.5. Let's see if that's one of our options, and that's not. Whoa, okay, so what did I do wrong? What do we want? What is the area in the square of a trapezoid which is formed by two triangles? 88. Okay, that's right. 13 times 11 divided by 2, 71 plus 44. I got 115.5. So negative 6 and negative 7. Negative 6, negative 7. So that's 7. Yeah, 7. Yes. So let's do the red triangle. So this is 7 plus 4 is 11. That's my height. And my base is, oh, okay, my base, I forgot. Here's my base. My base is not 8. My base is 6. That was my mistake. So 66 divided by 2, 33 units squared, and 71.5 plus 33 gives us 104.5. I don't think that's an answer too. Ooh. So I'm definitely doing something wrong. Let me count this again. So negative 6 negative 7 B negative 6 and 4, so my height is 11 for, right, and then 1 2 3 4 5 6, that's okay. So let's see, triangle, the blue triangle, the height is 7 plus 4, it's also 11, and my base is 6 plus 8, which should have been 14. Oh my god. Okay. It's 14 times 11. 14 times 11, which is 154, divided by 2, that gives us 77. Right. And then I'm going to add that plus 33 is 110. Okay, so my answer is going to be 77 plus 33, which gives us 110 units squared. Hopefully there's 110 here, and there isn't. Oh my god, okay. So let me just do the problem all over again. we can forward the video. What did I do wrong? Okay, so this is the area of trapezoid ABCD, which is formed. So I wanted the area of the trapezoid. All right. A, -6, -7. B, -6 and 4. A, B, C, 2, -7. Okay, so I have a triangle here. Now find the area of that triangle. Base times height. My base is 1, 6, 7. No, it's not. Again, I'm doing this wrong. Wrong with me. Because C is 2, -7. 2, -7. Okay, sorry. So my base is 8. Because this is 6 and this is 2 is 8. So my height is going to be 7 plus 4, which is 11. 7, right? From here to here, 7. From up here is 4. So 7 plus 7 is 11. Divided by 2, so my area is going to be 88. Divided by 2 is 44 units squared. So that's the area of my blue triangle. Red triangle. C, 2 and -7. Okay, and then D, 8 and 4. 8 going across and 4 going here. That's my second triangle. So for the red triangle, my area is this base, which start from here, 6 to the y-axis is 6, plus 8 is 14. My height is 11. 6 plus 8. 6 plus 8 is 14. Height is 11 divided by 2. So 14 times 11, or just 7 times 11, is 77. And then 77 plus the 44, this is 11, carry the 1, 121 units squared. Please tell me there is that answer. And there is, and we have letter B. Okay. 34, which expression is equivalent? So let's see, what I can do here to make this expression a little smaller is combine like terms. So I have 3x, 3x. Let me erase this. So this is, remember we went to this, circle the 3x with a sign preceding it, and then 14 and 10. So I can put the like terms together, and then I can combine them. So 3x plus 3x is 6x. 14 plus 10 is 24. So this is a little simpler version of that expression. Now, which of these 4 equals this? Well, let's use this really probably. 4 times x is 4x, so that's a no. 3 times x is 3x, so that's also no. 6 times x, oops, there we go, 6x. And 6 times 24, definitely not 24, so that's gone. Last one, 6 times x is 6x. And 6 times 4 is 24, so the only possible choice is D. 35, consider the trapezoid below. What is the area of the trapezoid? Now, nice here that they gave you 3 triangles that are inside this trapezoid. You can use base times height divided by 2 3 times, or you can do this, B1 plus B2 divided by 2. So I would do this because it's probably less work. My height is 4. This is my 4. Base 1 is from here all the way to here, and that's made up of this base of this first triangle plus the base of the second triangle. So base 1 is 12. B2 is on top. Doesn't matter if you call this B2 or the bottom B1. And then this one is also 6 divided by 2. 4. 12 plus 6 is 18, and then we're going to divide by 2. And we're going to get that the total answer is 36. Multiply 4 times 18 is 72. Divided by 2 is 36 square inches. And we have our answer. Sabrina had $40. She paid $D for lunch, and she had $40. Represent the amount of money she has left for, so it's going to be 40. She spent $D, and then minus $0.5 for stack. Which expression represents there you go, how much money she has left? Well, if she has 40, so let me rewrite this. Okay, she has $40. She spent $D for something, and remember this D has a coefficient of 1 if we don't see it, right? And then she went and bought something else for $0.5. So 0.5. Again, let me do this. Spent 1D for something, and then she spent 0.5D for something else. So let's calculate how much she spent. 1D plus 0.5D is 1.5D. Okay, we add the coefficients and we leave the variable, so 1.5D. So that's how much she spent. What did she have? She had $40, and then if you subtract what she spent minus 1.5D, you're gonna get whatever her money left. Right? So which expression looks anywhere like this? It has to be this. First of all, well, I guess maybe you didn't have to do this as long as you knew that if she has $40 and you want to find out how much she has left, obviously the only operation that would be useful is a subtraction, right? You wouldn't use multiplication, you wouldn't use addition, and you definitely didn't use division. Okay, so all that, and maybe you didn't even need this. You could have just understand that you had to subtract. 41, 43, or 37. A piece of wood is 3. Here's a piece of wood. It's 3/4 of a meter long. It's going to be cut into pieces that are 1/10 of a meter. So it's 3/4 of a tenth, and I'm gonna make 1/10. This is obviously not to scale. This is 1/10 meter long. So how many of these can we get out of a 3/4 meter? They're not even asking us to, to find out how many pieces. They're just asking which equation can we use. So, well, if I had this much, I want to cut them down into 1/10 meter. So it'll be, this is what I have. To find out how many of these fit inside the longer board, I would divide. Now, that would be what I do, and notice that each of these multiple choice have a multiplication. So, remember that one way of dividing fractions is to actually take 3/4 and multiply by its reciprocal. Okay, so the answer, the multiple choice answer is in this way, in a multiplication format. Okay, so if any of the choices A, B, C, or D look like this, 3/4 times 10 over 1, well, definitely not this. Check. No. And no. Right? It's 3/4 times 10 over 1. If they did have this, like this, that also obviously would be valid because multiplication is commutative and it doesn't matter which one comes first. But hopefully, and they did write it in this way. So the only one that works is 37B. 38. Which makes this bigger. I can't. Which of these shows the greatest ratio of dollars to hours earned? Okay, so 4 choices or 3 choices? So ratio, dollars to hours more. So let's see, can I compare this as a 2, every 2 hours you get $16. You know what I can do? I'm gonna put another 1 hour here. For letter A, what happens when it's 1 hour? If it's 2 hours, $16. Can't speak. What's the relationship? Times 8, times 8, times 8, and you'll notice that times 8 works for everyone. So 1 hour would be, I would get $8 for table A. The same thing here. right? Remember when I asked you when we did this with the winking and the jumping jacks, we had to find something in common. In this case, the easiest one is to find is the 1 hour. So for each of these tables, find what happens when you work 1 hour. So here, table B, 1 hour, you would make, what's the relationship? Times 6, times 6, times 6, you would make 6 hours. Table C, again, put a 1 over there. So go backwards. You notice that the relationship is times 9, times 9, times 9. So in this table, you would make 1 hour, bring you $9. And I'm just going to scroll down for a second. And the last table, 1 hour, it's a times 7, as you notice, it's times 7 times 7. And so that means that if you were to write 1, get that right, 1 hour would bring us $7. So which one has the greatest ratio? Is that the question? Ratio of dollars earned to hours earned? Well, the biggest one would be letter C, because 1 hour gives us $9. So this one would be choice C. Okay. 40. Which equation is true for any value of y? So pick a value. And in this case, let's see, 0. Hold on a second. 0, 2, 0. If you pick a value of 0 and you substitute, so here you have to see which of these where is. Don't pick a value. Ignore what I said. They're asking here, is the left equal to the right? In A, B, C, or D. So which one is it true? Now the problem is that we didn't do, not that we didn't do that, but 6th grade, you guys don't, we don't do multiplying bases with exponents. So let's see what we have. Is 4y times 4y plus 2 the same thing as 4y squared plus 2? Well, the plus 2 is the same, right? But 4y squared, you notice that if I multiply 4y times 4y, I'm going to get 16, right? Which is therefore not equal to this 4. So this one already is not the same. So A is out. B. 4y squared plus 2, 4y plus 4y. So what's 4y plus y? They're both like terms, aren't they? So remember there's a 1 over here. 4y plus 1y equals 5y. So already this 4y and what do you call it, this y are not the same. There's 4y plus y is 5y, which is definitely not equal to 4y squared. Besides the fact that these are y's, the first power, and this is the y to the second power. So this is gone. This one, let's do this. So if you did the distributive property, you get 4 times y, which is 4y, plus 4 times y, which is another 4y, plus 2. 4y plus 4y is 8y plus 2. That definitely doesn't look like anything on this side. So C is also gone. Now for D, and here's what I was talking about. The answer is D, but you guys, we didn't do that. Y times y. We didn't learn that multiplying multiplying bases are the same. We can add the exponent. So for letter C, although C is the answer, one thing you could do here is pick a value. Let's pick a value of 3 when y equals 3. So over here we get 4 times 3 to the second power plus 2 equals 4 parentheses 3 times 3 plus 2. We did all the order of operations. 3 to the second power is 9. 9 times 4 is 36 plus 2 is 38. On this side, 3 times 3 is 9, plus 4 is, 3 times 3 is 9, times 4 is 36, and plus 2 is 38. So you know that this is equal. You can use, pick another value. If you're on the test and you're not too sure, pick another value. See if it works for both sides. And if it does work, that's probably most likely the right answer. Because the other one, obviously, I sort of proved it, that, the coefficients at least were definitely different. 40. The library has at least 5,000 books. So it means that it has 5,000 at least. So it has 5,000 and it has 5,001, 5,002, 10,000. We don't know, but it definitely has the smallest number of books that it has is 5,000. It's 5,000 and greater. So number of books, 5,000. So number of books in that library definitely has to be equal to 5,000 or greater. Is there anything that looks like that? Yes, there is. That'll be 41 page was assigned, but she solved the first. She finished the last time. My problems page assigned. Okay. She solved the first 32 of the problems before dinner, and 32 problems before dinner, and she finished 20% after dinner. Okay, how many problems were assigned? Was assigned to page? So 32 problems. If she finished 20% after dinner, what does that mean? It means that she finished 80% before dinner, right? And what does 80% mean? It means 32 questions, because the question says she finished 32 problems before dinner. 32%, 32 problems represent 80%, because there was 20% left after dinner. Okay, so that's how I got my 80. Because if there's 20% left to do after dinner, that means she finished 80% before dinner. And I was also given that she finished 32 problems, which means it's 80%. So I want to find the total. It's 32%, 32 problems represent 80% of the problems. What's the total? So a mystery number stays here. Is there a relationship? No, but I can reduce this to 8 over 10. Right? Divide by 10, divide by 10. And now there is a relationship. Times 4. Times 4. And that gives us 40. Well, the only one that's correct is C. So this one's a little tricky in understanding that if she's going to finish 20% after dinner, it definitely meant that she finished 80% before dinner. Okay. 42, we want the net of the prism. We want the surface area. Okay, so the surface area is the sum of all these. We have 3 triangles, 3 rectangles, and 2 triangles. So let's do the area of the triangles. Area of the triangle is a base, and this base right here is 13. The height of that is 12. I'm going to divide that by 2. And I believe it's going to be 96. 13 times 12 divided by 2. No, 78. Okay, so I have 2 triangles. The other triangle on the other side is also 13 times 12 divided by 2. So I get 2 triangles with 72 units. And then I have this rectangle over here, which is a 26 by 13. My apologies. I'm going to start this problem all over again. This triangle, the base of that triangle is a 10, first of all. The height is a 12, so this height's a 12, and I got that from here. So it's 10 times 12 divided by 2, okay, which is 60. And I have 2 triangles, so the other triangle is also 10 times 12 divided by 2, which gives us 60. And now I'm left with 3 rectangles. This is a 26 by 13 area of that first rectangle, and I'm going to shade it. That's a 26 by 13. It's going to give us 338 units, inches squared. The rectangle in the middle, this one, is a 10 by 26, right? This is a 10 by 26. It's a little bit different. So the area in the middle is 10 times, or 26 times 10. sorry, 26 times 10, it's going to give us 260. And the area of this last rectangle is the same thing as the one on top. Okay, and that's going to be a 26 times 13, which is 26 times 13, which is going to give us 338. So the total surface area of this triangular prism is 338 plus 338 plus 260 plus 60 plus 60. That's going to give us, I have no idea. $1,056. But guess what? She wants to wrap 6 of these packages. So we're going to times that 6. And we're going to get 6,336. $40-something, 3. I plan to represent the first ever rectangle. What could be the other 2 points that he plotted? Well, let's see. 6 and 5, 6 and 5, that works. 6 and 6. A is gone. That's not a rectangle. B, 7 and 5, that works. 7 and 1. Is that a rectangle? It is. Done. Don't even bother with the other one. 5 and 8, that's not going to work. So the answer is B. 44. Hockey game has 3 periods of 20 minutes each. Colin plays 12 minutes each period. Which ratio shows Colin's playing time compared to total minutes of possible playing time? Well, Colin played 12 minutes 3 times. There's 3 periods, right? So he played 12 minutes in the first period, 12 minutes in the second period, and 12 minutes in the third period for a total of 36. So his playing time, we're going to compare his playing time, is 36. As compared to that, to the total amount of minutes. Well, the total amount of minutes is 20 minutes for the first period, 20 minutes for the second, 20 minutes for the third. That gives us a total of 60. So the ratio is 36 to 60. Neither of them look like this, so we have to do some simplifying. 36 to 60. Let's simplify this. We can divide this by 6, which is 6. Divided by 6, which is 10. Is there anything that looks like a 6 over 10? No. Let's simplify that even further. 6 divided by 10 is 3/5. Divided by 2 and divided by 2, I get 3/5. And there's something that looks like that, which I should have done initially by just simplifying by 12. 45, which point is a reflection of point R. All right, so nothing here. All we gotta do is draw. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. R is -2 and 9. -2 and 9 is -1, -2, and then again, we'll just estimate. So assume point R is here. -2 and 9 up. So we'll call that R. We're going to reflect this over the y-axis. So let me put X here and Y. So reflection over the y-axis, we're going to go from here, and it's going to go here. Remember a mirror? So on the other side of the y-axis, right here, same distance, the same distance. Now that's called R prime. Then we're going to take that R prime, and we're going to reflect it over the x-axis. So we're going to cross. So our first reflection went that way. Now our second reflection is going to go from quadrant 1. We went from quadrant 2 to quadrant 1. Now we're going to go from 1 to 4 because we're going to jump over the x-axis. So the reflection of R prime is all the way down here. Same distance. This is the same distance. Right? Same distance. And we're going to call that R double prime. Right? And in this quadrant, everybody is positive, and the second number is, what do you call, negative. So, is there any of these that is positive? Well, negative is definitely not it, because otherwise it means that the point is here. It's not. It's in quadrant 4. Negative, nope. 2 and -9, positive, negative. There we go. And it's the only one that actually makes sense. This looks like a 1, 2, and then all the way 9 down. So final answer is C. Because D says it's positive 9, which is all the way here, and then negative 2 right here. That's definitely not where it would land. 46. On which day did the low temperature change the most? I mean, table compared to the day before. So from Wednesday to Thursday, how much did it change? The table shows a change in the low temperature in Albany compared to the day before. The table shows a change in the low temperature. I see. So let me erase this. Compared to the day before, so this is Wednesday, and let me write a Tuesday here. Whatever Tuesday was, the temperature, let's just assume it was 0. On Wednesday, it went up 3.5. So there was a change of 3.5. So wherever it was, and let's just, for example, say, assume it was a 0, it went up to 3.5. There was a change of 3.5 degrees. 3.5 degrees. Maybe 0 is not a good example. So let's just assume there was a change of 3.5. So wherever the temperature was, so wherever you were in your temperature, okay, whatever temperature it was, it went up 1, 2, 3.5. That's what they're saying. From Wednesday to Thursday, and then on Thursday there was a change of negative 4.1. Well, minus 4.1, it means that it traveled 1, 2, 3, 4.1. That's how much it changed. It got colder for sure, right? Because it was a negative, so it got colder, but the temperature change was 4 degrees, 4.1 degrees. On Friday, 0, so apparently the temperature stayed the same. And then on Saturday, again, from wherever the temperature was, it dropped 1, 2. So which of these 4 days did the temperature change the most? So they're not asking for the biggest value, but they're asking which day the temperature changed the most. And the day the temperature changed the most was Thursday. It got colder. It changed the most. Okay, not that it got colder. I take that back. Okay. Multiply the sum of a number and 3. So multiply the sum of a number and 3. Let's get the sum of a number first. And let's multiply that by 3. No, multiply the sum of a number and 3. Here's the sum of the number and 3. We'll multiply this times the difference of 8 and a number. There we go. Sorry. Number and 3 times 8. It has to be in parentheses, so here we go. A number and 3, number plus 3 times 8 minus b. So this is the only. This has to be protected by parentheses. Both actually have to be protected by parentheses. Okay, because we're adding these two, and then we're going to multiply that by the subtraction of these two. Okay. 48. Okay, so this is the park ranger station. Okay, so always nice to draw these. Problem is I can't draw it. So that's 0 because it's sea level. Here's a mountain, and just pretend a mountain on this side goes here. So that would be still sea level. Says here that the park ranger station is negative 21. So if this is 0, let's just assume that on this side of the mountain, on this side, it's negative 21. That's the park ranger. And the visitor center is negative 21. The visitor center even negative 29 feet. Kind of makes sense, visitor. Okay. Which statement is true? Since negative 29 is less than negative 21, the park ranger station is at the higher elevation than the park visitor center. That's true. Since negative 29 is greater than negative 21, you can already ignore that. Since negative 29 is less than negative 1, the park visitor center is at the higher. Nope. And since negative 29 is greater, that's also no. So you can eliminate B and D right away because negative 29 is not greater than negative 21. Okay, and the other two was just a matter. See how this little map really comes in handy, right? Negative 21 would be here. The park ranger station would definitely be higher than negative 29. Okay. 49. There's 17 adult dogs and 8 puppy, which is correct. Ratio of dogs to puppies at the park is, so ratio is actually 17 adults to 8 puppies. That's our ratio. So this one is not true. The ratio of dogs to all dogs is 17 to 8. Well, no. The ratio of puppies to adult dogs, there's 8 puppies. To adult dogs, no, there's 17, so it would be 8 to 17, so this is also not true. The ratio of puppies to all dogs at the park is 8 to 25, so there's a ratio, there's 8 puppies, and how many dogs in total? Well, the total would be 17 plus 8, which is 25, so that's the only one that's true. What are the coefficients? Coefficients are the numbers multiplied to the variable, so we got 8, 12, and 5. 8, 12, and 5. 5, 8, and 12. Not this, because that has a 7. And negative 8, 5, and 12. Let's stop this for a second. So 50, where is it? 50 is, here we go. So the coefficients are negative 8, 12, and 5, so it's negative 8. This is a 12, and that's a 5, and we have our coefficient. The answer is B. 51. This video is really long. 51. Which point of corner plane represents 5 and negative 3? 5 over. Negative 3 is down, so it's be point R. So answer is A. Okay. 52. So 1 batch of cookies. So 10 cups raisins. You can make 5 batches of cookies. So if you're going to make, how many cups of raisins are in 1 batch of cookies? So if you want to make 1 batch of cookie, how many cups of raisins? So this is a proportion problem. How many cups of raisins would you need? Well, divided by 5, divided by 5, you would get 2 cups of raisins. Okay. What's the value of this expression? 5 to the second power is 25. 4 to the third power is 4 times 4 times 4, which is 64. That's going to give us 91, 81, 25, no, 89, sorry. 54. Okay, 2 more. So, this has a negative number. I hate when they do this. T is the time in seconds after the object's drop, which is the best how far above the ground the object will be after 8 seconds. So here's your formula. It's a nice physics formula. plus 1454. Okay, where t is the time, which is the best? So how far above the ground will the object be? So negative, and then 16 t to the second power, so we have times 8 to the second power plus 1454. Hopefully you have a calculator. I doubt you're not going to see a question with negative numbers, so don't. I'm just doing this because it's there. So we get negative 16 times 64 plus 1454. Negative 16 times 64 is going to be a negative, so 16 times 64 is going to give us negative 1024, and then we're going to add that to 1454, and then the final answer is going to be 1454, 430 feet. You can ignore this question, okay, but if you wanted to attempt it, that would be how far it dropped. So just, in other words, after 8 seconds, this is how much the ball traveled. Right, if the height of the Empire State Building is 1,454, after it dropped, after 8 seconds, the ball traveled that much, that distance, and if you subtract these two, it means that the ball is still 430 feet up in the air. Okay. Last question. Jason gets paid $20 for 4 hours. $20 for 4 hours. He gets $30 for 6 hours. And then I'm going to write this one, $50 for 10 hours. Which equation shows how much money Jason gets paid per hour H he babysits? What? Jason gets paid $20 to wait for 4 hours, gets paid $30 for 6, $50 for 10 hours. So the ratio here would be 1 hour divided by 4 is 5 hours. I mean $5, sorry. So let me just see something. So here he gets $5. In 1 hour, right, divided by 10 would be $5 an hour. And divided by 6 he gets, so he gets $5 an hour. M equals 5. So the total amount of money he makes, it would be $5 times the number of hours he makes. So I just didn't see this. Sorry. So you could have done a table. 420, 630, 10 and 50. It's probably easier if you saw it by table. So this is the hours. This is the money. It's a times 5, times 5, times 5. So he gets $5 an hour. So final answer is B. Okay. So hopefully, fast forward those questions you don't need to really look at.